And welcome, function folks, to lesson 2.2, an introduction to rational functions. Even though we've been talking about rational functions for a couple of days now, it feels like this is our first time we're going to actually be talking about rational functions in general. Now, the 3-minute review, and hopefully you've tried this, this is a review of, number 1 is a review of grade 11 transformations. Number 2 is a review of our transformations of functions notation from unit 0, that sort of thing. And the thought cloud there is just to remember you can think of these sorts of things whenever we talk about a function, and I'll mention that in a second. The graphs, how I graphed the parent function 1 over x is I'd think of this, there's only a couple of nice points on this graph, 1, 1, and -1, -1, and then I think of the asymptotes, and then you can graph that quickly. And then the other ones happen to be transformations of this. This one, the +4 is in with the x, that's left 4, and this is up 1. Now notice what happens when we move left 4 and up 1, the asymptotes move with that transformation. So left 4, I should have used a different scale, but left 4 is this one moves 1, 2, 3, 4, left 4, and then that's the vertical asymptote x equals -4, and up 1. So where the asymptote was there, it gets moved up 1, up 1. And all of the nice points, which isn't many, I realize, moves the same way. Left 4, 1, 2, 3, 4, and up 1, up 1. And then the shape hasn't changed. We still have the same x and y, or sorry, the same nice points. Okay? That's that function, and this is just a review of transformation of functions. It just seems like we review this all the time. Here, I would consider this minus, because there's our parent function right there. I would think of this as a vertical flip, right? So there's my parent function. The negative is outside affecting y values. It's not in with the x. So I would think of it being flipped from here to down there, right? This is kind of the intermediate step, and then this piece gets flipped. This gets flipped from here to here. Now, what's the equation of this dotted green one? That's going to be y equals -1 over x. Then what does the +3 do to it? Moves everything up 3. So where the horizontal asymptote was at 3, it gets moved up 3. That's the new horizontal asymptote at 3, and everything gets moved up 3. All the important points, and so on. I'm actually going to draw that one in, so I'm getting too many dotted ones, right, with a little arrow at the end to show the asymptotes. And that gets moved up 3. Dotted one gets moved up 3. 1, 2, right there. Notice that these rational functions are a special kind that can be written as transformations of my parent function y equals 1 over x. Yet last class we did another special case of rational functions, which was reciprocal functions. And notice one way to graph this one would be to graph the bottom, because it is in that reciprocal form. But we could do this last year, and this is a review of what's going on last year. How would I think of this? I would think of this as this is all in with the x. So I'm thinking of these as transformations in the direction of x. So here, this is a flip in the direction of x, so this way, a flip horizontally. And multiplying by 3, you think should expand it, but in the direction of x, it compresses it by a factor of 1/3. Right? You think multiplying by 3 would expand it, but it compresses it, and it also moves it left 1 unit, opposite that you'd think in the direction of x. So here, flip and compress. So Flip would be this point ends up here, but then compressed to 1/3 of that, which is maybe about there. And then, in fact, all the points, no matter where they are flipped and compressed. Flipped and compressed, flipped and compressed. Still an asymptote, though, even though this one's way out there. Flipped and then brought back 1/3. Flipped, brought back to 1/3. Now, this isn't my final graph, right? This is the graph y equals negative 1 over negative 3x. And then I needed to move this whole thing left 1. So when I move things left 1, the vertical asymptote moves left 1. And all the important points get moved left 1. All the important points get moved left 1. And then I get my and this is a review of grade 11 stuff. X plus 1, kind of a mess. Yours looks better than mine as normal. Dandy. Okay, what's the last part? The last part was to write these functions in this transformation notation. So this one, because the plus 4 is in with the x, looks like this, and then the plus 1 on the outside. So what's this one? I'd have h at x, the negative is out front, nothing in with the x, and plus 3. And this one, a at x is equal to everything's inside with the x, so I think of it as everything being inside with the x. And there are other ways to have thought of these one, especially this one. And if you didn't quite get that or you saw that differently, make sure you ask about it in class. Okay? A pretty long 3-minute review, 7-minute, 3-minute review. But let's get on with today's stuff. Today is an introduction to rational functions. Rational functions. And there's a lot of little tiny bits and pieces of things that we want to be able to do today, and so this is a bit of a longer lesson. What is a rational number? Well, a rational number, you'd think of things like this, right? A third and, you know, negative 7/8 and so on. But it's also things like decimals, even repeating decimals. In fact, it's anything that can be written as a over b, where a and b are both integers. That's what a rational number is. A and b are both integers. Z is the set of integers. With, of course, b, we can't divide by 0, so we also have to say b cannot be 0. And that was maybe, I don't know, grade 8, grade 9, you talked about rational numbers, fractions that can be positives and negatives. Anything that can be written as a fraction like this. What is a rational expression? This is what we talked about last year. Essentially, a rational expression, we thought of, you know, we'd have expressions like this, and we could add them and subtract them and multiply them. We actually had that for some of our review. Basically, it's any polynomial over a polynomial, right? Polynomial over a polynomial. So what's a rational function? A rational function would be the next thing. And we've talked about this difference between functions and expressions and that sort of thing. This is where it's the answer, an expression, is equal to something. So we have y equals p at x over q at x. Or, you know, we could use our function notation. Grown-ups use function notation, where p and q at x are both polynomials. Polynomial expressions. So essentially it's what we had last year in grade 11 with a y equals or an f at x equal to it. Notice that in the same way when we had rational numbers, b couldn't be 0. Same thing here, q can't be 0. And we saw problems when the bottom was 0 already. That's the idea of asymptotes, even though we'll see something weird happen with that. Q at x can't be 0. So there's a rational function. Definition for a rational function. I'll pick up the next bit, next couple of slides in part 2.